Okay, this is going to be a video on the rationals graphs. Okay, it's a sample test. Okay, so this one here has been factored for us. Okay, so what I got here is this would eliminate this x minus 2, which means that hole is at x equals 2. Okay, all right, now what I got left over is basically this part here. So my vertical asymptote's at x equals -3. Okay, I don't have a slant asymptote. I'm sorry, I don't have a horizontal because basically this degree is one bigger. So I know I have the slant. So what I want to do is I want to do long division. Okay, with x squared plus x minus 6. So I need something to multiply to x squared to get that. That'd be that. So it'd be x squared, I'm sorry, x cubed. That would be positive x squared. That'd be negative 6x. Okay. This goes away. I'm doing subtraction and subtraction. So it would be negative 4x squared. And that would end up being positive 2x with a plus 12. Okay, I need this to be negative 4 to get that exact term. Negative 4 times that is negative 4x. Negative 4 times that would be 24. Okay, that goes away. Minus and minus, which would be 6x. That'd be 36. So that'd be negative 12. Okay, so that'd be 6x minus 12 over this stuff. Okay, now the only thing that really matters for us is that the y equals x minus 4. Okay, all right. All right, so now I want to take that information, okay, and I want to go ahead and I want to make a graph with that. Okay, so my vertical asymptote at -3 would be here. Okay, I would have my horizontal or my slant asymptote at this is -4, so 1, 2, 3, and 4. The slope there is up 1 over 1, up 1 over 1, up 1 over 1. So I would have something that looked like this. Okay. All right. Now, what I have to account for in my graph, okay, so what I want to do is I want to graph what was left over, so x minus 3 at times x plus 2, all right? So I'll have to be a little creative with here. Parentheses, parentheses, x plus 3, that's what I'm doing. No, x minus 3. X plus 2. Close the parentheses, divided by x plus 3. Okay, so I got that. I'm going to zoom out a little bit so I can see that. All right, so I know I have that slant asymptote. Okay, G solve root. I got a root at -2. Okay, if I hit over, I get the other one, which is a 3. 1, 2, and 3. Okay. I got my y-intercept, G-solve y-intercept at y equals -2, which would be here, okay? Now I also want to find G-solve max, which is -5.44, -11.89. -5.44, -11.89, okay? I also want, and I want to graph that point, -2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, and a bit. Okay, so there's that point. G-solve minimum, -0.55, -2.10. Okay, so that's -0.55, 1, 2.0. Okay, all right, so those are going to be important for me when we get to the domain and range. Okay, so now what I want to do, okay, my vertical asymptote was -3. So I want to look at -2, -1, 0, -4, -5, -6 as far as points go. Okay? All right, and I also have to account for my hole. My hole here was x equals 2. Okay? All right, so I have to account for the hole as well. All right? So I go ahead over to the table function. I put the hole in as 2. All right, that's 2 and -0.8, 0.8. All right, so 2 over, all right, negative. So that'd be right there, okay? All right, then I want to get these other points in here. So I got -2, which is 0, I got that already. Okay, -1, which is at -2, okay, and 0, which is at -2, which I already have, okay. Then I want to do -3, I already got that one, -4, which is -14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, okay. At -5, okay, I have -12, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay. Okay, yes, that should be more like here. Okay, and then -6, which is -12. Wait. Oh, that's interesting. It's about the same. Okay, so somewhere in here. All right. So I got my shape looks like this. My shape looks like this. Okay. All right. So I have to be careful with the domain. This is going to be x is all real numbers, but x can't be my vertical asymptote of -3, and x can't be where my hole was, which was 2. My range is y, is all real numbers, okay? All right. Now, actually, no, I don't want to put that. So I want to go below, so I'm going to go -infinity to -11.89, union -2.10 to infinity, okay? All right, because that works its way up, okay? All right, that's probably the most challenging one of all of them. Okay, this one, I want to factor it. Okay, so that's going to be factors of -40. That'd be -20 and 2. That would add up to that. Okay, so I got 5x squared minus 20x plus 2x minus 8. So that'd be x and 5x. That'd be 2. That'd be -4. So I got 5x plus 2, x minus 4. Okay, this one's pretty easy. This is going to be x minus 4, x plus 2. So that eliminates where my hole would be x equals 4. Okay, what's left over would be 5x plus 2 over x plus 2. So my vertical asymptote is at x equals -2. In this situation, I have a tie, this and this, so that would be y equals 5. That would be none. Okay, I would want to go to menu and graph, and I want to put 5x plus 2 divided by x plus 2. I want to draw that, g-solve root. I got x equals -0.4. G-solve y-intercept, y equals 1. Okay, all right, and I can see the shape there. Okay, all right, so I'm gonna graph that at x is -2 is my vertical asymptote. My horizontal asymptote is 1, 2, 3, 4, and 5. I'll get to the hole in a second. My x-intercept is -0.4. My y-intercept is 1. Okay, all right. Now, when I go to the hole, my hole here is 4, so I'm gonna have to account for that. All right. So when I go into the table, that's the first thing I'm gonna take care of is that. All right. I'm gonna put 4 in there, and I get 3.66. Okay, so 4 over 1, 2, 3, and 4. 1, 2, 3, and 0.6. So I'm gonna put that little hole there. I'm gonna have to account for that in the domain and range. Okay, now since my vertical asymptote is at -2, okay, I want to look at -1, 0, and 1, -3, -4, and -5. Okay, so I'll put in -1, I get -3, 2, and 3. I put in 0, I get 1, which I already have, and 1, I get 2.3. Okay, so that's that side of it. And then -3, I get 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and then -4, I get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then -5, I get 7.6. 1, 2, 3, 4, 5, 6, 7, and a bit. So my curves look something like this. Boom, boom. okay? All right, now, I got domain is x is an element of all real numbers, except x can't be my -2, and it also can't be my whole, okay? My range, y is an element of all real numbers. Y can't be 5, y can't also be 3.66. Now, it's only important that you care about that with the whole, with the range, because it's unaccounted for, okay? Moving on to the next problem. Okay, so this one, real easy elimination. Cross off, okay? So that's going to be, my whole is going to be x equals -3/2, okay? My vertical asymptotes at x equals 5. What's left over here? Just this. So I've got a horizontal one at y equals 0. I don't have one of these, okay? All right, so when I go into the graph, okay, all right, I want to graph 1 divided by x minus 5. All right, probably want to zoom in a little bit for that. G-solve root, I don't have one. Exit draw, G-solve y-intercept, I got y equals -0.2. Now I don't need to check for minimum maximum because this is not a slant asymptote, okay? So let's go down. All right, at x equals 5, okay, that's 1, 2, 3, 4, and 5. Okay, I've got y equals 0. I've got an x-intercept of -0.2. All right, now when I go to the table, first thing I got to account for is that whole of -3/2. Okay, so -3 divided by 2 gives me -0.15. Okay, so that's like -1.5 over. That's 1/2 over. That's down. So something like that. Okay. Now, since my vertical asymptote is at 5, I want to be focused around 5, 6, 7, and 8, and 4, 3, and 2. Okay. So 6, I'm at 1. At 7, I'm at 0.5. And then 8, I'm at 0.3. At 4, I'm at -1. At 3, I'm at -0.5. And 2, I'm at 0.3. So I got this through the whole. Okay. So the domain, x is an element of all real numbers. X can't be the 5. X can't be my -3/2. Y is an element of all real numbers. Y can't be 0. Y can't also be -0.15. Okay? Moving on to the next question. Okay? All right? So, what I should try to do is I should try to factor this. So I got x plus 3, x minus 3. Okay? This one is the one that's the 2-part by 3-part. Okay? That cube root of that is x minus 3, x times x squared, -3 times 9. All right, remember I got to multiply those, which is -3x, and change the sign. Now, what eliminates is x minus 3, so I got a whole at x equals 3. Okay, I've got my final result at x squared plus 3x plus 9, all over x plus 3. Okay, and since that's bigger, I'm going to have a slant asymptote. I have a vertical asymptote at x equals -3. But I'm going to have a slant asymptote here. Okay. So x times that would be x squared. X times that would be 3x. Minus a minus, that's 0x. With a plus 9. So that's going to be plus 0. And that'd be 0x and 0. So it's going to be, it's going to be 9. Okay. Now, what my slant asymptote is y equals x plus 0. All right. So let's go ahead. I'm going to go ahead and put what's remaining into the calculator. That was x squared plus 3x plus 9 divided by x x plus 3. okay? And that's drawing, and you see, I can see I have a minimum and maximum issue here, okay? So my vertical asymptote, as we saw before, was at x equals -3. So that's 1, 2, and -3. Okay, I've got a slant asymptote, 0, up 1 over 1, up 1 over 1, up 1 over 1. Looks like that. All right. Let's see if I can find G-solve root. I have none. G-solve y-intercept, I got y equals 3. So that's right here, okay? I have to account, all right? I got that so far. I also have to do the G-solve max, which is -6, -9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 5, 6, 7, 8, 9. 6, 5, 6, 7, 8, 9. Okay, that's gonna be my maximum there. Okay, G-solve minimum, 0, 3. 0 over 1, 2, 3 up. Okay, all right. And so those are those points in there. So when I go to the table, I also need to account for the hole, which the hole was at 3. So 3 and 4.5, that's gonna be the hole. All right, 3 over, okay, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5, so that's right there. Okay, now as I do the vertical asymptote, my vertical asymptote was at -3, so I want to be focused around -2, -1, and 0, -4, -5, and -6. Okay, -2 is -2, 7. 1, 2, 3, 4, 5, 6, and 7. -1 is 3.5. 1, 2, 3, and a bit. 0 I already have. Okay, -4 is -13. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. -5 is -9.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, and a bit. And then -6 I already have on there. So I know my shape looks something like this and something like this. Okay? Now, as far as the domain goes, this would be x is an element of all real numbers, except x can't be -3, x can't be 3, because that's the whole. The range, okay, since we're worried about this and this, okay, this would be, this would be -infinity to -9 union 3 to infinity. Remember, we only care about the y's. Don't have to worry about the whole, it's accounted for on the other side. Okay, this one, there's nothing to factor. My vertical asymptote is 3/4. My horizontal asymptote is y equals 3 because I have a tie. 12 divided by 4 would be 3. None for this, none for this. Okay, so what I want to put into the calculator, into the graph, is 12x plus 5 divided by 4x minus 3. Okay, so something like that. Okay, so G-solve root, I got a x equals -0.4 is that. G-solve y-intercept, y equals -1.6. Okay. All right, so what I got here is I got a vertical asymptote at 3/4. I've got a horizontal asymptote at 3, 1, 2, and 3. I've got an x-intercept at -0.4. I got a y-intercept at -1.6. Okay, all right. So since my vertical asymptote is at 3/4, all right, I'm just going to go 1, 2, 3, and 0, -1, -2. Okay, all right. So let's go to the table. All right, menu and table. Okay, all right, so at 1, I'm at 17, that's way off the chart. 2, I'm at 5.8. 1, 2, 1, 2, 3, 4, 5, and a bit. 3, I'm at 4.5. 1, 2, 3, 4, a little bit, okay? All right, and then 0, I'm at negative 1.6, I already have that, okay? At negative 1, I'm at 1, and then negative 2, I'm at 1.7. So this is what this one looks like, heads there that way, this one heads that way. All right, so I got domain, x is an element of all real numbers, except x can't be 3/4. Y is an element of all real numbers, but y can't be 3. There was no holes, so I didn't have to worry about that. Okay, going on, I believe this is the last question. Okay, all right. So what I got here is I want to factor this. This is very simple factoring. Okay, so what would happen is that would eliminate. So that whole would be at x equals 1. I would have 1 over x plus 2. So my vertical would be x equals -2. My horizontal would be y equals 0, and this would be none. Okay, it's at y equals 0 because the x power is bigger. Okay, so I want to graph 1 over x plus 2. Okay. Okay, draw. All right, g solve root. There's none. G solve y-intercept. Y equals 0.5. Okay. So at -2, I got this. This is horizontal. Okay. All right. My y-intercept's at 0.5. All right. Now, when I go to the table, I have to account for the whole, which was 1. Okay, that's something that's big as I go to the table. And I put in 1 for the table. All right, that's 0.3. Okay, so 1 over 0.3 up, that's going to be here. Okay, now, since my vertical asymptote's -2, I'm looking at -1, I'm looking at 0, and I'm looking at 1. All right, and then also -3, -4, and -5. Okay, so -1, I'm at 1. At 0, I'm at 0.5, and 1, I'm at 0.3. Okay, so I'm pretty good there. Okay, all right, and then I got -2. I'm sorry, -3, which I'm at -1. Okay, and then -4, which is a -0.5, and then -5, which is this. So I'm doing one of these. Okay, and I'm doing one of these. Okay, all right, counted for that. So for my domain, x is an element of all real numbers such that x can't be -2. Also, x couldn't be 1. Y couldn't be 0, and also y can't be 0.3. Okay, and so that is a review on how to do the graphing rationals.